We're talking about asymmetric warfare. In this explainer, we're going to walk through a highly detailed chronological scenario based on recent tactical analyses. We'll be looking closely at exactly how top-tier militaries try to counter mass-produced, low-cost threats. So let's dive straight in and look at the actual mechanics of swarms, stealth, and what the future of defense really looks like.
Imagine the scene. It's the pitch-black early hours of May 28, 2026. A fragile ceasefire in the Persian Gulf is suddenly pushed to the absolute breaking point. Alarms start blaring across the combat information centers of U.S. warships. Radar screens light up. 4 Iranian one-way attack drones are airborne, tracking at incredibly low altitudes right over the waves, heading straight toward commercial shipping and a U.S. carrier strike group. In a split second, the tactical environment goes from 0 to 100.
Section 1. The Persian Gulf Swarm Attack.
Okay, so the immediate threat here comes from the Shahed series. These are mass-produced one-way attack drones specifically designed to slip right beneath standard radar coverage. And because they fly so unbelievably low, your heavy land-based strike fighters, they just aren't the right tool for the job. Instead, the immediate aerial response falls to the carrier strike group. They spring into action to counter a swarm that's explicitly designed to overwhelm traditional defenses. But here's the kicker. While the fleet is tracking the skies over the water, a far more critical countdown is happening on the ground. The clock is at 15 minutes. Deep within a compound near the strategic port of Bandar Abbas, a 5th drone is being fueled and prepped on its mobile launch rail. It has less than 15 minutes until ignition. If that drone launches, a secondary wave begins. So U.S. Central Command doesn't just have to neutralize the airborne threat, they have a rapidly closing window to stop that next launch.
Section 2. Electronic warfare and interception. Stopping that airborne swarm falls to 4 deployed FA-18 Super Hornets, vectoring in at high speed. But here is the fascinating part. They actually don't fight alone. They rely heavily on their electronic bodyguards. Trailing just behind the interceptors is an EA-18 Growler. Inside its rear cockpit, an electronic warfare officer is managing a multi-million-dollar electronic jamming suite. And the exact methodology the Growler uses is just brilliant. See, these drones rely on pre-programmed GPS coordinates or active radio command links, right? Well, the Growler's job is to break that link. Step 1. Isolate the precise encrypted data streams traveling between the drones and the land-based launch site. Step 2. Blast high-powered directional energy bands directly at the targets. Step 3. Sever the command link completely. Blinded and losing their telemetry, the drone swarm's coordination instantly collapses. Once that electronic blinding takes effect, the Super Hornets move in and totally capitalize on the confusion. Using AIM-9X Sidewinder missiles, which are these highly agile infrared tracking weapons, the fighters lock onto the tiny heat signatures of the drone's small piston engines. Or, if they want to conserve missiles, the pilots can just switch to gun mode. At that point, it literally becomes a game of pure old-school skill, aligning the crosshairs and shredding the blinded drones right out of the sky over the open water. Section 3. Striking the launch source. So, the immediate swarm is down. But what about that countdown? U.S. Central Command needs to sever the kill chain entirely before that 5th drone at Bandar Abbas can launch. But they face a huge dilemma here. They absolutely cannot risk sending manned aircraft inside Iran's heavily integrated and highly defended airspace. They need a precision standoff strike, and they need it instantly. So the assignment goes to a U.S. Navy guided missile destroyer positioned securely out of range. Erupting from the ship's vertical launch system, their weapon of choice, the Tomahawk cruise missile, drops to a low altitude. It uses advanced terrain contouring radar to physically hug the landscape, staying entirely below the detection threshold of coastal early warning radars. Guided by GPS and digital scene matching, it calculates a terminal dive with absolute surgical precision. And the result of that precision? An immediate, direct hit on the ground control station at Bandar Abbas. The strike triggers a massive secondary explosion as the fuel and payload of that 5th drone detonate simultaneously right on the launch rail. In a single action, the command hub, the launch mechanics, and the remaining threat are entirely vaporized. The immediate kill chain on land is completely broken. Section 4. The million-dollar jet intercept. Now, the battle space in asymmetric warfare is incredibly wide. While the Bandar Abbas strike is happening, a secondary threat emerges 500 miles away, off the southern coast of Iran. An Iranian drone carrier has launched a Shahed-139, directly targeting the USS Abraham Lincoln, a Nimitz-class aircraft carrier sailing toward the Strait of Hormuz. Just tracing the timeline of this interception reveals some incredible technological steps. At T-15 minutes, an airborne E-2D Hawkeye, and the fleet's Spy-1 radars detect a low observable contact on a collision course. At T-minus 5 minutes, an F-35C Lightning stealth fighter is vectored in. The pilot uses advanced sensor fusion and a helmet-mounted display that literally projects the drone's location directly onto their visor, tracking it right through the clouds and darkness. T-minus 1 minute, visual confirmation is made. The drone ignores warnings. T0. The pilot fires an AIM-9X Sidewinder, destroying the airframe instantly.
This whole sequence sets up a pretty stark comparison. On one side, you have the F-35C Lightning stealth fighter. We're talking about an asset that costs roughly $100 million. On the other side, the Shahed-139, a mass-produced loitering munition that costs around $70,000. This, right here, represents the absolute core of asymmetric warfare. It is a massive financial imbalance between the attacker and the defender, which leads us to a central intellectual puzzle of modern combat. Why? Honestly, why use a multi-million-dollar jet to shoot down a relatively cheap drone? Why not just use the ship's own guns or close-in weapon systems? On paper, it looks like total overkill, right? But military doctrine isn't just about the cost of the weapon used. It's about the cost of what that weapon is actually protecting. So the answer to that puzzle comes down to 3 tactical pillars. Number 1, defense in depth. Think about it. If a drone is shot down by a ship's guns, it's already within 2 miles. That is way too close for comfort. An F-35C intercepts it 50 to 100 miles away, which gives the fleet time for a second attempt if the first one actually fails. Number 2, visual identification. A radar blip can't tell you if a drone is carrying a camera or a warhead. A pilot can. And number 3, de-escalation. A fighter jet can signal a clear warning. If the drone ignores it, the intent is undeniably hostile, which completely justifies the use of force.
Section 5, Iran's ballistic retaliation strategy.
Now, in our scenario, the destruction of the drone site definitely does not go unanswered. Strategically, Tehran must respond to deter further intervention, and they certainly have the hardware to do it. They need to prove to the region and the world, really, that despite taking a significant hit, they retain massive fighting power. Because despite that devastating U.S. strike on Bandar Abbas, roughly 30 to 40% of Iran's missile launchers in the region remain completely intact. And that is more than enough to execute a coordinated, multi-domain approach combining their remaining missile arsenal, drone capabilities, and proxy forces to overwhelm defenses. Mapping out that retaliation reveals their likely high-value targets. A primary target would absolutely be the Al Udeid Air Base in Qatar. This base hosts 8,000 American troops and serves as CENTCOM's regional headquarters. To strike it, they'd likely utilize ballistic missiles like the Fateh 110, which has a 300-kilometer range. Or they might target naval support activity in Bahrain using the Qiyam-1, capable of reaching 800 kilometers. All of this while simultaneously utilizing proxies to strike bases in Kuwait and the UAE. To maximize the lethality of these ballistic strikes against sprawling air bases, these missiles would likely employ a very specific mechanic, the airburst. Now, an airburst is a proximity-fused detonation that occurs just above the surface. By exploding in the air rather than upon impact with the ground, it maximizes fragmentation and drastically increases the affected damage area. It's designed explicitly to destroy parked aircraft, radar installations, and any personnel caught out in the open.
We've seen the incredible technology used to defeat these swarms today, from electronic jamming to $100 million stealth fighters, but it leaves us with one incredibly provocative question. Can high-end militaries actually sustain the cost of using million-dollar weapons to fight thousands of cheap drones? As technology becomes more and more accessible, this cost-exchange ratio will literally define the future of global security. Thank you so much for joining me for this explainer. Keep questioning, keep learning, and I'll see you next time.